So today we're looking at the notes for factoring and special cases. So first, when we're factoring in special cases, we need to know the perfect square numbers. And what perfect square numbers are the answer to if you take a number and square it, what do you get? So when you take 1 squared, you get 1. And when you take 2 squared, you get 4. And when you take 3 squared, you get 9. So as you go through, you could go ahead and fill these out real quick. I'm going to pause the video and do all these and then come back. So if you would pause the video, come back. So these are the perfect square numbers. If you need to pause the video and double check your answers, that's fine. So what happens is there are types of trinomials that are perfect square trinomials. And what that means is the first value is squared. That's your A value. It's squared. Your B value is squared. And then in the middle, you either have negative 2AB or you have positive 2AB. Now, this is different than the actual ABC technique that we have been using. We'll talk about those in a second. One that shows up much more often is called difference of squares. And the first thing I want you to identify is, what does difference mean? Difference means subtraction. Okay? And in difference of two squares, it actually won't be a trinomial, it'll be a binomial. The first term has to be a perfect square, and the second term has to be a perfect square. Okay? Therefore, a squared minus b squared is going to equal a plus b and a minus b. This is actually, this part right here is actually on your reference sheet. Here's what it looks like in practice. So what I'm going to do is I'm going to look at problem number 3 right here. And I'm going to do our normal method, which is ABCs first. So A, B, C. My A value was 4. My B value, there's no M, so M is times 0. So that's 0. And my C is negative 1. That's step number 1, right? Well, first look for a GCF. There's no GCF. Okay. Step number 2, X. 4 times negative 1 is negative 4. B value is 0. So you need two numbers when they're multiplied together that give you negative 4. Well, one of and combined to give you 0. So one of them is going to be 2, and the other one's going to be negative 2. Now, we have a couple of different methods on this next step. I normally go with the box method. So if I go with my box, my first one is 4m squared. My second one is negative 1 down here. These other boxes in the top right and the bottom left, one is negative 2m and the other one is positive 2m. Sorry, those look pretty far away and I was writing pretty small, so I wanted to bring those up a little closer. Okay, so we have 4m squared, negative 2m, 2m, and negative 1. So now we fill out our areas around the box. So we have m and m. Here we have negative 1. I look for a spot where I know my multiplication has to be something. Like here, this has to be 1 and negative 1, right? And because the negative goes down the column, that means this is negative 1 and this is positive 1. So therefore, this works in this bottom right corner. So now I'm going to move up. Here's negative 2. What would I have to multiply by negative 1 in order to get negative 2m? Well, I would need 2m. Okay, I'm going to work my way around. What would I have to multiply 2m in order to get 4m squared? Well, I would need another 2m. 2m times 2m is 4m squared. And then I work and confirm this. 2m times 1 is 2m, so that works. So my two binomials, one is 2m plus 1. The other is 2m minus 1. And when you look back to the rule states if we find the a value is squared and the b value is squared, then it would be a difference of squares, a plus b, a minus b. So here, my A value was actually 2m squared. My B value in this is just 1. So that's how like the difference of squares work. Remember, you can still go through this process. Your B value is 0. It does allow you to, if you remember this and you see this in this case, for example, actually, we'll talk about problem number 2. In this case, I know that 49 is a perfect square. It's 7 squared. I know that 16 is a perfect square. It's 4 squared. And this C value, it's also squared. So if I went through and did this entire thing, my answer here would be 7 minus 4C, 7, actually I'm going to change this, 7 plus 4C, 7 minus 4C. Now, if I went through this entire process and did it, would it be wrong? No. I could still get this factored pair. But the important thing that you need to remember are these. If you want to make this jump, the important thing is remember that it's a difference, it's a binomial, and that both of the terms are perfect squares. So if you're looking at problem number 4, yeah, this is x squared. I agree with that. This is 5 squared. But the problem is that difference. That's not difference. This is not factorable. Because it's not a difference of squares. It has to be difference. It has to be subtraction. Again, there is nothing wrong with doing this method to confirm your answer and make sure that it's right, especially if it's complex and it's not the numbers that you can see. Here, my very first example isn't too bad. My A value would be x squared. My B value would be 8 squared. So you would have x plus 8, x minus 8. Perfect square trinomials. This is when the entire piece is written out together. So what they're saying here, I'm going to use number 8 as an example. What they're saying here is if the first value is squared, so x squared, okay, that's obviously x is my A value. This is b squared, so what times itself equals 36? Well, that's 6 times 6. And the part in the middle is doubled and then multiplied the A value and the B value. So my B value was 6. I have to double it, so 6 times 2 is 12. And then multiply by my A value, that is 12x. And this is all addition. So if I go through the factoring process, how this is going to end up is this is going to end up as A plus B times A plus B, or A plus B squared. Let me show you. A, B, C. A, B, C. My A value, 1. My B value, 12. My C value, 36. Step 2, X. A times B on top, that's 36. B on bottom, that's 12. What multiply together to get you 36, but add together to give you 12? That's 6 and 6. Because my A value is 1, I can skip the box and say x plus 6, x plus 6. So this is x plus 6, x plus 6, which again is x plus 6 squared. So because this is a method that shows up, we can create this rule where if we find the pieces, x and 6 in this case, we can say that we can jump from here and conclude that A plus B squared. Okay, A and my B value squared. The difference here, when it's subtracting, it's actually going to be A minus B a minus b, which is a minus b squared. You don't have to memorize these because, as you can see, going through our normal method, we can get our answer. So that's the note for factoring in special cases. These three, this one, along with these two, are on the top part of your reference chart. It's a faster way in special situations and in special cases. But always, if you're comfortable with this, you can always go back to the ABC and the Xbox method.